Okay, so the next thing we're going to look at are graphs of the cosecant and the secant. To graph your cosecant, which remember is going to be the reciprocal of sine, so 1 over y, we're going to take the reciprocals of the y coordinates of the points from the graph of sine. In a similar fashion, when we're graphing secant, we're going to take the reciprocals of the x coordinates of the points from the graph of cosine. So you can see how these graphs are formed when you're plotting them on the same graph as their reciprocal function. So for the cosecant, if you were to graph sine, remember the reciprocal is just 1 over your sine value. So 1 over 1 is going to be 1. Okay, 1 over 0 is going to be what? It's going to be undefined. So what happens there? That's where you're going to have an asymptote. Now in between, you're going to have values that are decimals, and that's fine. It's just when you put them over 1, you're going to see a reflection of those points here. Okay, and it is going to be your reciprocal. Again, at pi, see how it's at 0? So if you were to do the reciprocal, 1 over 0, it would be undefined. So we're going to have an asymptote there. At -1, 1 divided by -1 is going to be -1. Okay, so this is what it's creating. It's creating parabola-like shapes here, where you have your asymptotes at x equals -pi. Here you have one at x equals pi. Right here you have one at x equals 0. Now, when you're graphing the one period of 2 pi, notice that this is one period here. So you have one parabola opening up and one opening down, but you still have asymptotes in between them. Okay, so this one is more than one period because you have more than just one parabola going down and more than one going up. Now for the secant, it's going to be very similar. If you look at the graph of cosine, right, here's where we have 1. Well, 1 over 1 is going to be itself. Here, 1 over 1 is going to be itself. And then whenever you have 0, okay, 1 over 0 is going to produce an asymptote. So we can see our asymptotes are here at x equals pi over 2, at x equals 3 pi over 2. And here's a graph that spanned out a little bit further. So now you can see here that this is going to be your point of 1, 0. Okay, right there. And that's because when you do your reciprocal, you know that you're going to get 1 over 1, which is going to be 1. Okay. Oh, and this is 0, 1. So I must have just labeled 0, 0. Okay, so this point here is 0, 1. This point here is 0, 0. Alright, and then this point here, this would be pi, and then at pi, I'm at -1. So that would be our point. Okay, and then that's going to keep repeating itself. Now again, one period is still going to be one parabola opening up, one parabola opening down. It's really easy to see from here, -3 pi over 2 to pi over 2, because all of those units are going to be 2 pi. If you counted the units, there's 1, 2, 3, 4. If you have 4 units of pi over 2, 4 times pi over 2 is going to be 2 pi. Bada bing, bada boom. Now, if you're looking at this, you can think of, oh, if I put these two together, it would make a full upper parabola. So you have one upper and then one lower. All right, let's talk about the next thing. So what do you notice about the asymptotes here? I said that the cosecant of x, that's going to be the reciprocal of sine, and it's where sine is undefined. Your secant of x, it's going to be the reciprocal of cosine, and that's where it would be undefined. So it's where the sine of x equals 0, where the cosine of x equals 0, they're going to occur at the undefined points. Okay, so you can put that into your own words. Now for tangent and cotangent curves, here's your general equation. Y equals a tangent of kx, y equals a cotangent of kx. Remember the period for tangent and cotangent is pi over k, but for secant and cosecant it is 2 pi over k. I'm sorry that it is shaking. My camera's basically on the top of a bobblehead here. All right, so example 1, we are going to find the period and graph the function. So y is going to equal 1/2 cosecant of x. So when we're finding the period for cosecant, it's going to be 2 pi over k. K is in front of your x value, so it's 1, so it's just going to be 2 pi. So to obtain your new graph, you can multiply the y coordinates of each point on the graph of y equals the cosecant of x by 1/2. So if we look at our original graph of the cosecant, for our cosecant, we can see here that it started at 0, well, this is your sign. It started at pi over 2, 1. So if we multiply that by 1/2, okay, at negative pi over 2, well, actually, it started at pi over 2. So at pi over 2, you're going to do 1 times 1/2, and you will get 1/2 here. So I scaled mine by 1/2. Okay, and then at 3 pi over 2, you're going to look at your graph again. You can see it's negative 1. If you multiply that by 1/2, your graph will be at negative 1/2. Okay, at 3 pi over 2. And if you look at pi over 2, you're at 1. So if you do 1 times 1/2, you're going to be here. So what I do is I plot those first, and then you're going to find your asymptotes. So we don't have any shifts here, so your asymptotes are going to occur at the same places. So you're still going to have it at 0, pi, 2 pi, negative 2 pi. Okay, and then just make sure you identify the asymptotes with the dashed lines, and then I like to label them at the top, especially if it's y equals 0. Okay, so because you have the 1/2, that's going to be a vertical compression by 1/2. So you are just going to multiply your y values by 1/2 to find your new vertices. And then once you do that, you can make your graph. Okay, and then you could also plug in points into the equation if you were having trouble with that. So if you wanted, you could do y equals the cosecant of x and say, okay, at pi over 2, it's 1. So if I multiply by 1/2, the y is going to be 1/2. At 3 pi over 2, it's negative 1. If I multiply that by 1/2, it'll be negative 1/2. So my new point is going to be 3 pi over 2, negative 1/2. Okay, and then I also asked you, do you know how to graph on your calculator with the correct intervals? So if you are graphing this on your calculator, what you have to do is you have to put this in radian mode. And if you put this in radian mode, you have to use the reciprocals. So the cosecant of x equals 1 over the sine of x. Okay, so if you want to do that real quick, you can. Again, you'd have to go to mode, change it to radian mode. When you're doing your x-axis, I would put in negative 2 pi to 2 pi. Now it's going to change those to decimals automatically, which is fine, but you can still do your scale the way that we have it there. Okay, so we're going to change our mode to radians. I'll actually show you this. Okay, so if you have your mode, I'm already in radians. I'm going to go to y equals, and it's 1/2 the cosecant. So you can do 0.5 times 1 over sine, or you can do 0.5 divided by the sine of x to graph it. Oh shoot, sorry, I forgot to show you my window. Yay! Okay, so I already have mine at negative 2 pi, so negative 2 pi, and then 2 pi here, and then I said I'm going to go by pi over 2, and then I just left my scale the same there. So then you can see your graph, and then where you have the openings, that's where your intercepts are going to be.